Okay, this is question number 3, which is from the paper 2 questions. Let's do it. So we've got f of x, and f of x it says is that function for there. Following diagram shows the graph of f. It intersects at x equals 0, got it. X equals p, got it. Maximum at point A, where x is A, and the inflection is at x equals B. Okay, so we've got all of those. So I'm just making sure. Yeah, we're good. All right, so the first question is we want to know what that um, intercept is. Now, because this is a paper 2 question, my approach is going to be using my calculator. Your calculator is absolutely your best friend on any paper 2 question. So I think if you just get used to graphing almost immediately, I think your life will be a lot easier. And I know that I'm setting all of these up and it's wasting time, but hey, let's have some fun. You can always watch this at 3 times speed or double speed, make it easier. So the value of point P, that is going to be when the original function is equal to 0. If I wanted to go through the work, I totally could, where x to the fourth minus 54x squared plus 60x is 0. I can divide an x out and I get x times x cubed minus 54x plus 60. Now, that's a cubic function. I really don't necessarily want to deal with that cubic. I have an idea what this is going to turn out to be, but what I'm going to say is rather than doing this analytically, let's use our calculator. So if I just pull up my calculator, I'm going to add a graph page, and I'm going to write actually my original equation. So I know I did all that work analytically, but now I'm telling you to skip all that because there's really no reason to. Well, we have a calculator. X squared plus 60x. Now, what we are looking for, because we're only looking for this first intercept right there. We know that this thing has got to cross at the x-axis, and that's what that's showing. So what I'm going to do is I'm going to do a analyze graph, and I'm going to find the zeros. Now I'm just going to pick before that intercept I'm after, and then after, and my answer is going to be, what I would do is I would just show a quick sketch of the graph. I would circle my intercept, and here it's 1.14 comma 0. That is the value of P. So P is 1.14. I should probably do an approximate because I'll guarantee you that's rounded. Next, it wants you to find the coordinates of A. Again, you have options here. Option number 1 is to try to do this analytically, but you'll get with another cubic. So while we could totally do that using differential calculus, let's just go back to our graph, and I'm going to zoom this thing way out. Actually, I'm just going to switch my window settings. I have no idea how high this thing goes, so I'm going to start with 25 and see if I get to it. Lo and behold, I do. So now I just have to find what this maximum is. So menu, analyze graph, maximum. If I pick between those 2 points, my max is at, so for B, I'm going to do that same trick. Quick sketch of the graph. I'm going to circle point A, and point A was at 0.56 comma 16562 comma, and then 16 point, sorry, my brain is not working, 16.8. So those are the coordinates. So A is 0.562, 16.8. That is my answer for B. Next up, write down the equation to the tangent of the graph at A. Okay, well, the tangent, the equation of the tangent is always going to be y equals mx plus b. Okay? Looking at this graph, point A, that is a max. What is the slope of the line when we're at a maximum? Well, it's just going to be a horizontal line. So the first derivative is 0. So writing this again, what's going to happen is this is going to end up being, my graph is going to be y equals 0. Oh, sorry, my y was 16.8, 0 times 0.562 plus 16.8, well, actually, sorry, plus b has to be 16.8. Well, this all cancels, so we find that b is 16.8, so my equation becomes y equals 16.8. All right, so that's all that we have to do to find that one. I think that's manageable. Up next, find the coordinates of point B. Okay, so point B, we've been told, is the inflection point. We find the inflection points. Inflection points happen at where the second derivative is the same as 0. Okay, so if the second derivative is 0, we'll have our inflection point. So all I have to do is I have to take this original equation, x to the fourth minus 54x squared plus 60x. That's my original equation. I'll do my derivative in green. So 4x cubed minus 108x plus 60. So that is my first derivative. Now my second derivative is going to be the same as 12x squared minus 108. Whew, good times. All right, so now I just have to figure out when this equation, when that expression equals 0. So if I do that, 12x squared minus 108 is 0, so 12x squared equals 108. X squared is 108 divided by 12. I think that's 9, because 9 times 10 is 90, and 9 times, yeah, that's 9. So x is plus or minus 3. Looking at the graph, it's got to be positive 3. So the point of inflection is at the point x equals 3. I just want to make sure, find the coordinates of that point of inflection. So now I have to take this and substitute it back into the original equation. I got it up there. So that is silly to me. I'm just going to use my calculator. I'm going to do menu, trace, graph trace, and I'm going to type the number 3, and it tells me that that is at negative 225. So this is going to be 3, negative 225 would be my answer. Okay, we're there. And lastly, we have to find the rate of change of f at b. So this just takes a little bit of mental gymnastics. The rate of change of f of x at b? Well, we also know that b is actually 3. So where just the x value is. So it's when, so what that's going to be is the first derivative evaluated at 3. Okay, so looking back, my first derivative was 4 times 3 cubed minus 108 times 3 plus 60. Okay, again, this is where our calculator is our best friend. Sorry, I just got to move around so I can actually see my equation. All right, 4 times 3 cubed minus 108 times 3 plus 60, negative 156. So the answer is negative 156. There, I hope that's helpful. I hope that makes sense. Good luck.